Hello everyone, welcome back to my YouTube channel. Myself Prashanth. I'm studying in Sri Venkateswara College of Engineering, Bangalore in the Department of Computer Science and Engineering. Today I'm going to discuss the topic about the definition and example of the Klein 4 group in the discrete mathematics structures. Klein 4 group. In mathematics, the Klein 4 group is an abelian group with the 4 elements, in which each element is a self-inverse, nothing but the comparing it with itself produce the identity, and in which composing any two of the three non-identity elements produces the third one. The Klein group with 4 elements is the smallest group that is not cyclic. Up to isomorphism, there is only one other group or order 4, the cyclic group of the order 4. Both groups are abelian. If it is a Klein 4 group, what are the features it should be have? What are the features it should be contains that is we are going to discuss now. First one is order. It has 4 elements. If it is not had the 4 elements, it is not a Klein 4 group. Then the abelian, it is abelian nothing but it should follows the commutative, meaning order of operations does not affect the result. Then next one is self-inverse elements. Self-inverse elements nothing but the every element in its own inverse. Next one is isomorphism. Isomorphism, if here one example is ZC, it is a isomorphism to Z2 and Z2R. The direct product of two cyclic groups of order is 2. This is nothing but the isomorphism. Next one is Boolean group representation. It can represented as 0, 1, 1, 0, 1, 1, and 0, 0 under the component wise addition of 2. These are the features it should follow when it is a Klein 4 group, or else it will not a Klein 4 group. Now let's concentrate on the examples of the Klein 4 group. Symmetry group of a rectangle. The Klein 4 group represents the symmetric of a non-square rectangle including horizontal reflection, vertical reflection, and a 180-degree rotation. This is the example of the Klein 4 group. Bitwise XOR operation. It can describe the group of bitwise exclusive or nothing but the XOR. In short form, we are going to call it is as AXOR operations on 2-bit binary values. Next one is a direct product of cyclic groups. The Klein 4 group is a isomorphism to Z2 cross Z2, Z2R. The direct product of two cyclic groups order is 2. This is the one of the main example of the Klein 4 group. Next is the continuation part of the examples. Next, group theory in discrete mathematics structures. What do you mean by a group theory? Nothing but discrete mathematics structures. It is studied analog alongside with groups like additive groups of integers modulo n, multiplication groups of modulo p, and the permutations group. These are the main examples or the group theories we are used in our discrete mathematics structures. Next one is Boolean representation. Boolean nothing but it is a true or false. In DMS, how we can represent, see here, it can be represented as a set. We are going to take in a set. The set contains the 4 elements, what that is 0, 0, 0, 1, 1, 0, and 1, 1. These are the binary numbers of a set under the component wise addition modulo 2. Here we are going to use the modulo 2 because it is a two numbers binary, two variables binary set, that is 0, 0, 0, 1, 1, 0, as well as the 1, 1. Now the conclusion of the Klein 4 group. What are the topics we discussed today is in this session is what is the main definition of the 4 Klein group, and the some features what it should be contain, what it should be obeys the Klein 4 group, and the features of this Klein 4 group and the examples. The Klein 4 group V4, nothing but it should have the four orders. It is a fundamental example in the group theory with unique properties that make it a valuable study in the DMS, nothing but discrete mathematical structures, as a non-cyclic abelian group with the four elements. What are the four elements? Nothing but associative, associative, commutative, inverse, and the identity. Identity. Those, if it is a abelian group, it should follow the four. It should obey the four properties. Those are the inverse, identity, commutative, and the associative. Next, it serves as an essential building block for the understanding the symmetry. When we are going to talk about symmetry, or we are going to understanding about anything about symmetry, it should be, we are going to first analyze or whatever the client for group is there. Now first we are going to start with this topic. Later on we are understand the symmetry of the particular method, then the Boolean algebra and the modular arithmetics. These are the building blocks for the understanding symmetry, Boolean algebra, and the modular arithmetics. Okay, thank you everyone. Please like, share, and subscribe to my YouTube channel.